Hello, welcome to the next tutorial. So in the previous one, what we have done was we have tried running the simulation and it ran perfectly. The next step can be to refine the mesh and see the results. This can be the one of the steps. And secondly, we can run the simulation for the longer duration or for the large number of steps. If it is transient, then for the longer duration, and if it is a steady state, then for the large number of steps until it meets the convergence criteria. So it is a judgment. So let's study this with an illustration. So I suggest that we are having this thing, that we are having this the snapshot of the control deck that has been followed by the spoken tutorial, and we will be going accordingly. So let's see. Okay. So where are we? Here. We have been running gedit. So here we are having this control deck, and the spoken tutorial has modified it according to this. So we will also modify the same. Application is icofoam, start time 0, end time, and it is 5. Instead of 0.5 it is now 5. Then delta t is 1 e power minus 2, which is 1 e minus 2, and then right interval is 100. Right interval is 100. Purge right is to ASCII of in general as you can. So basically, we have already discussed all of these values. In case you are having any kind of doubt, please refer to this spoken tutorial. They have explained it really nicely. So long story short, we are having an end time of zero point 0.5. So initially we ran the simulation to zero point 0.5 seconds, and it ran. So we can now enhance the duration. Okay. So we are just for the illustration purpose, we are going ahead with the zero point 0.5 from 0 to zero point 0.5. Now the simulation will start again from 0. And delta t is what? Delta t is this with the right interval of 100. So we'll be having the values of 0.01 into 100, meaning 0, 1, 2, 3, 4, and 5. Only these many folders will be writing down. Yeah, we are good to go from here. So we'll just save it. It got saved. So closing gedit, and yeah, let's go to the folder cd space dot dot, then cd pipe. Okay, let's remove other folders. Okay, so what is that? Rf minus Rf. So I want to remove all of the folders starting from 0 and having a point with any kind of number. This star meaning 1, 2, 3, 4, 5, everything. So let's put as enter, and then let's say ls. So we have removed now everything. So please try to learn these kind of shortcuts in between, wherein those are here to make our life easier. So with this, let's run again. So what is that? Maybe control it. So that let's jump directly to the solver. So icofoam. So till now it is running. It may take a while to okay, finished. So it took around 21 seconds to go, and then we can see that the current number appreciation is not much. It is kind of constrained, and it is going well. The residuals are under control. The iterations, okay, so the number of iterations are higher at this point, meaning the pressure is finding it difficult to converge. Yeah, the iteration for the pressure parts are really high. The iteration for pressure part are high. and we are having one more iteration for the others with the residual is under control. So yeah, it looks somehow good to me. The tolerance that we have put in here is 1000. So here it seems that the pressure is finding it difficult to convert, but yeah, for the sake of this tutorial, we are okay, and we can go ahead. Now we are having a very important thing to discuss as to how far we need to refine the mesh. Number one. Secondly, we need to discuss about how far we need to run the simulation. Let's say initially we have discussed about zero point 0.5. We did check it finished instantly, and then we have jumped paraform and everything we did. I mean, just open the results in the paraform, and then we concluded the last tutorial. So there are two things. You refine the mesh till you get the same result. It is called as grid independent study. So whatever the parameter that you are examining is, let's say your probe parameter is u. Let's say based on the you are refining your mesh. Let's say the mesh should be fine near the walls, and you make it refined near the walls. Okay, and then overall you try to balance your computational expenses along with the accuracy of the solution. So grid independence is one of the fundamental study that we do for any kind of simulation first. So the simulations till the simulations we did till now were just for the demonstration purpose as to how you run a simulation. Okay, while the standard method includes the calculation of time constants, um, as to how far the simulation should run such that the steady state can be assumed, okay, for any transient solver. And after that, the change with time is significantly small, so that you kind of assume that it has reached a steady state. Ideally, perfectly it is not, but yeah, it is an engineering kind of assumption. So these are the two things worth conveying. First thing, just to summarize, first thing was the grid independent study, wherein you refine the grid such that your result is grid independent. Okay, you try to balance your grid. You try to mention some zones that okay, in this zone I want to refine more, and in that zone where I want to define I want to refine the less. It depends on the gradient on the parameter that you are examining in, and many other parameters. We'll be discussing about it a little more in future. But then for the time being, uh, this is about grid independence, and for the time, it is mainly applicable for the transient solvers. For the steady state ones, we need iterations, straightway iterations. So the control dict may the time takes the form of iteration. Let's say you are having the end time of your 5, and 0.01 is the delta t. So it will be 500 iterations because it is a steady state solution. While an icofoam is a transient solution, so it ran till the time of 5 seconds. So this is the 5 second of the geometry CFD time, and this is the clock time. So that for the simulation of the 5 seconds, you took around 20-21 seconds to finish the simulation computationally. So that's all for this thing. Hope you have got some insight, some value out of the discussion, and this learning series. Please let me know in case you require some further assistance or you have any kind of queries. Thank you so much. Let's meet in the next tutorial. Thank you so much. Thank you for your patience listening. Bye bye.